So we are discussing probability distributions, which is actually for non-statistical people, a little bit of dry subject, but I'll make it interesting. Okay, so we'll go through all the chapters. Today, we are going to talk about inferential statistics. All of you type IS in the chat box for inferential statistics. Life is all about guesses. All of you type GUESS in the chat box. Life is all about guesses. Now, how many of you are bachelors here? Type B in the chat box if you are bachelors here. Okay, there are quite a few bachelors here. The reason I'm saying is when you go out to see your fiancé, okay, the girl or the guy whom you want to get married out, you actually estimate their behavior and then make a decision. Yes or no? And you draw samples from the way that you move with them. Right? Jayesh Bhai says no. Okay, all the best. Most of the time, correct. And similarly, when we wanted to guess, how many of you have seen opinion polls? Type OP in the chat box. OP, opinion polls. After the election, there is always an opinion poll, right? Or before election, there is an opinion poll. And after election, there is something called as an exit poll, right? And in exit poll also, what they do is they take a large sample from the population, a lot of people, they take a sample and they guess. And that sort of decision making is called inferential statistics. Inferential statistics is a branch of statistics that makes use of analytical tools, okay, to make inference. All of you type AT in the chat box, analytical tools. Okay. Now, what are these analytical tools? I'm going to talk about many analytical tools, okay? Hypothesis testing. One of the things that I want to tell you about hypothesis testing, regression analysis, and stuff like that. So we have seen the descriptive statistics. There is a data, and we describe the data with mean, median, mode, okay? We describe the data with the range, standard deviation, variation, IQR, interquartile range and all that. That we saw in the last session. If you missed that, I'll share the video with you. Okay, you have to stay till the end of the session. But inferential statistics helps us draw a conclusion about the population. If I conduct an opinion poll of the sample and they say that party X will win, can I draw safely that yes, it is the representative of the entire population? So, hypothesis testing and regression analysis. All of you type HT and RA. These are the things that you should record. HT, hypothesis testing, and RE, which is regression analysis. These are the two important tools that is used for regression, for hypothesis testing. Sorry, for inferential statistics. Okay. Now, the samples are chosen and need to be representative of the entire population. You cannot choose only people who are wearing saffron colors and ask which party do you vote. Naturally, what will they answer? Suppose in India, somebody is wearing saffron and you ask which party did you vote. Naturally, which party will they say? Everybody will say BJP. So that is called a biased sample. Okay, don't do that. So inference is an act or a process of deriving logical conclusions from the premises. The act of reasoning from the knowledge. So it helps develop a good understanding of the population data by analyzing the samples. And we can make generalization about the population by various analysis tests and tools. So in order to pick the random samples that will represent the population accurately, many sampling techniques are used. Okay. So it is very important that for different ways of inferential statistics and different situations, we have to use different types of sampling techniques. And there are a few popular, 3 or 4 popular type of sampling techniques. Simple random sampling. All of you type SRS in the chat box. Simple random sampling. Let me quickly explain to you what is simple random sampling. For example, I have only 5 chocolates in the class. Let's say there are 100 students in the class. I wanted to give 5 chocolates. I have only 5 chocolates. I want to give randomly to a few people. I don't want to pick and choose, people who studies well, who is looking good, who is smart, etc. No, I don't want to bias myself. I wanted to randomly choose 5 people and give chocolates. Let us say I'm wearing a hat. On the hat, let's say on a small piece of paper, I write the names of one person on a small piece of paper, roll it, put it in the hat. Write the name of the second person on a small piece of paper, roll it and put it inside the hat. The third person, the fourth person, up to 100 people. So I have 100 pieces of paper rolled with the names written on each and every person. Put it on my hat, okay, or a basket, and shuffle it and pick 5 of them. I ask somebody to pick 5 of them, okay, and open and read the names. The 5 names come, and I give the chocolates to these 5 people. This is called simple random sampling. If simple random sampling is clear on a scale of 1 to 9, please give me a 9 or 10 if it is super clear. Fantastic. That is called simple random sampling. Generally, in election polls or in asking some opinions and stuff like that, simple random sampling is used. For example, if there is a lot of products that you have produced, and let's say 1,000 pieces are there or 10,000 pieces are there, you take some 100 pieces, it should be randomly taken. The second is called as, okay, the second I'll put systematic sampling. Okay, what is systematic sampling? Systematic sampling means, let's say that there are a lot of bottles that is being filled. Okay, you see Coke bottles or Pepsi bottles or whatever it is being filled, and millions of bottles are being filled. And you wanted to see whether the weight of the bottle or the quantity of liquid inside the bottle is okay. You cannot take random samples. Instead of taking random samples, because it's a continuous production, you systematically take every hour. Let's say 1 p.m., 2 p.m., 3 p.m., 4 p.m., 5 p.m., we take some samples. Okay, that is called systematic sampling. If systematic sampling is clear, type SC, super clear in the chat box. So systematically you take. It can be time-wise. It can be every 1,000 pieces. That is also systematic. After every 1,000 pieces, take some sample. Stratified random sampling. Stratified means you group according to some category. You group according to category. For example, I want to know different stores, because a supermarket can sell electronic items, can sell apparels, can sell footwear, can sell jewelry or whatever it is in a mall. So I wanted to find out where the customer spending is. Does customer spend more on food, or customer spend more on electronics? Does customer spend more on apparels or textiles? Does customer spend more on jewelry? Okay. In order to do that, I will see the customer expenditure, and I will also group them by electronics. I group them by number of sales in textiles, apparels, number of purchases in jewelry, etc. That is called stratified sampling, because grouping it by the category. If stratified sampling is clear, type CC, crystal clear in the chat box. That's stratified sampling. Super. Thank you very much. And cluster sampling. Cluster sampling is you pick 10 pieces at a time. Okay? From this lot, you pick 10 pieces. From that lot, you pick 10 pieces. From this lot. So there can be a systematic cluster sampling also. So these are all some sampling methodologies. Okay. The most commonly used are simple, systematic, stratified type of sampling. Okay, let's proceed a little further on this. The goal of the inferential statistics is to make generalizations about the population. In inferential statistics, static is taken from a sample data. What is this static? Okay, for example, the mean. The mean of, or the average of the sample is taken. The static. The static means the central tendency and the distribution. And this is used to make the inferences on the population parameter. So to draw the inferences about the population parameter, studied by modeling the patterns and observations. So the objective of Six Sigma is to move from only describing the nature of the data or descriptive statistics to inferring what will happen in the future without. Actually, just to break the monotony, I'll give you one example. Suppose I buy a machine, and the machine, let's say that I start a manufacturing industry of making a piece of automobile component, let's say a washer. Okay, I make the washer. I have this piece which is stamped. I want to make a hole in that. It should be a 10 hole. It can be 10 millimeters plus or minus 1 millimeter, which means that it can be between 9 millimeters to 11 millimeters. Now, I wanted to see whether the machine is producing all the pieces within 9 to 11 millimeters. So what I would do is, I would start the machine and then start making these pieces. Maybe you feed the piece one by one or it's automatically fed, but the holes are drilled. Now I'm measuring. Now there are, in a day, let's say there are some 10,000 pieces of such washers made. So I select a sample of 100 pieces and measure the diameter, the inner diameter, the drilled hole diameter. And then I find the average of this. Let's say the average is 9.8. Let's say average of 9.8. This average 9.8 is only of 100 pieces. Can I say the 10,000 pieces what I produced in a day, if I calculate the average, assume that I measure all the 10,000 pieces, the diameter, and calculate the average, will the average of 10,000 pieces, the diameter of this 10,000 pieces average and the diameter, which is 9.8 of this sample, will it be the same or different? Okay, some people say the same, some people say it is different. Okay, so this is what, and some people say it depends. But you have to conclude. Okay, let me give you an easier example. Let's say there is a president election in your college. There is a president election in your college. And there are 1,000 people in your college. And all the 1,000 people has voted. There are 3 candidates. Let's say all the 1,000 people have voted for candidate A, some for candidate A, some for candidate B, and some for candidate C. So I want to know who is the winner. I want to know who is the winner. So I pick up a sample of, let's say, 30 people randomly. I pick a sample of 30 people randomly. Out of 30 people, let's say 20 say candidate A will win. I mean, they have voted for candidate A. Let's say that 6 of them say that they have voted for candidate B, and 4 of them say they have voted for candidate C. So I have this sample of 30 people where 20 of them are saying candidate A. Can I say election is declared, candidate A will win? Who will win? If the election is declared, if the results are declared, who will win, A, B, or C? I will repeat again. 1,000 people have voted. Some voted for candidate A, some for candidate B and candidate C. I have taken 30 people out of this 1,000, or let's say even 50 people out of this 1,000. 30 of them said that out of 50, 30 of them said candidate A. 15 of them, 1-5, have said candidate B, and 5 of them said candidate C. So 30, 15, and 5. Candidate A, B, C. When the results come, who will be the winner? Let's see the answer. Okay, Charles Clark is saying, we can't say it. There is a plus or minus error. The error can be there. All right, good. Yeah, I'm not sharing my screen. Okay. I've just switched over. Okay, fine. Thank you very much. Okay, now that is what is the whole subject of inferential statistics, is to draw the conclusion about the population, which is 1,000, with respect to the sample that you have taken. Okay, it is similar to the example that you have 150 employees in the city. Not all employees from single business, but random employees from different companies. You might be able to use inferential statistics to draw a conclusion about working individuals. And that is why in descriptive statistics, we use mean, median, mode, and the spread also. And in inferential statistics, we use the same statistic for the sample. We take the sample and infer the population. Okay. Now, this is very important. We said there are two things in inferential statistics. One is hypothesis testing and regression analysis. Okay. Now, I wanted to go into this depth of hypothesis testing. What is hypothesis testing? Okay. Let's say that I wanted to bring in a scenario here. What do you see on the screen? What image do you see on the screen? Yeah, courtroom. Okay, fine. Now, there is something called as in hypothesis, there is a null hypothesis, which is H naught. It is like null hypothesis means, let's say that person A is there, and null hypothesis means he is innocent. He has not done the crime. Okay. Similarly, in production, if some samples are taken and if you get an average of the diameter is 9.8, you can safely say, okay, the population can also be 9.8. There is no difference. Okay, that is what is null hypothesis. Null hypothesis means no difference. No difference means, okay, the person is not special and has done a crime. He is a normal person. He is an innocent person. So prosecuting attorney must provide evidence. Unless you prove him guilty, he is innocent. How many of you agree with me? Innocent until proven guilty. So there must be an evidence that you should bring in order to prove him that he is guilty. He will be innocent unless proven guilty. Similarly, if you got the sample and the null hypothesis is candidate A will win, okay, and unless you prove the evidence that no, this is biased or something like that, then it is, you can safely say there is no difference. Yeah, whatever his sample says, the population also will be the same. But there is always a risk, and in statistics, we take the risk to be 5%. All of you type 5% in this chat box, and in aerospace, they will take 1%. In some satellite launch, they'll take 0.1%. But in general, mechanical industry or engineering industries, we take 5% risk. 5% risk means out of 100 times, 95 times we will be correct. 5 times we can still go wrong. Okay, that is called reasonable doubt, which is alpha. Now, type 1 error. Let us take the example of, this is going to be very interesting. Okay, all of you should focus here. All of you type FOCUS, focus in the chat box. I want everybody's focus here. This is going to be really interesting. Okay, thank you very much for your focus. So there is something called as a truth. There is something called as a decision. The decision might be in favor of truth. The decision might be not in favor of the truth. Okay. Suppose, so let us say the null hypothesis is the person who has been brought to the court, the accused, he is not guilty, he is innocent. And the decision is, I have accepted the null hypothesis, which is he is not guilty. That is the correct decision. Okay, if you are clear, give me a 9 or 10. The truth is, there is always a truth, right? He has not done the crime, and the judge has concluded that he has not done the crime because the null hypothesis is he has not done the crime, and hence it is a correct decision. In case the judge says he has done the crime, then that is a false positive. That is, the innocent guy has been punished. Okay, the innocent guy has been punished. That is an error. How many of you agree with this? Type agree in the chat box. An innocent because, and there is a 5% chance of punishing the innocent. Now I will extrapolate the same to, suppose if the truth is this guy is really done the crime, and if you have found the evidence and caught him and said yes, he is guilty, he has found the time, then that is a correct decision. If it is clear, type super clear in the chat box. The truth is he is guilty, and the decision is yes, the judge caught it, and you can type SC for super clear. Okay, so I will explain about the power later. Okay, but then this guy is guilty But if he has been let free, then it is type 2 error, which is false negative. Okay, if that is, or other words, the guilty person is let free. That is also a mistake. A person who is innocent is punished is also a mistake. A person who is guilty, who is let free, is also a mistake. This is called type 2 error. If type 2 error is clear on a scale of 1 to 10, please give me a 9 or 10 if it is super, super clear. This type 1 and type 2 is the heart of the hypothesis testing. If you found so far this explanation interesting, useful, valuable, fantastic, awesome, put it in the chat box, because I try to explain this in as simple words as possible. So now let me summarize that for you. The truth is, and there is a decision, let's say in the manufacturing company. Okay, the summary is, when the truth is guilty, if it is not guilty, he must be let free. That is a correct decision. But if he is not guilty and if you punish him, then that is type 2 error. At the same time, if the truth is not guilty, but the decision is you punish him, you are finding an innocent person guilty. And this guy is innocent person is let free is type 1 error. So this is a summary of type 1 and type 2. Okay, now let's take the manufacturing example. Let's put this box. Now some product is rejected. Some product is rejected. The truth is it is a defective product. But if you fail to reject a defective product, it is type 2 error. Let me ask you this question. Okay, before I explain this, I'll ask you this question. Suppose if it is rejected, okay, and it is sent to the customer, because we are not able to detect that it's a quality, who will be the sufferer? Your quality department did not do a good job of detecting the bad piece. Who will be the sufferer? Where will? Customer. Yes, customer. Okay. Good answer. I'll ask the other question. Okay. Suppose the quality department is oversensitive and started rejecting good parts. The quality department is oversensitive. It started rejecting good parts. Who will be the sufferer? The manufacturer, the company, the management. Correct. All the answers are correct. Now, with this context, let us listen to this. Okay. Now, this is called consumer risk because you have failed to reject a bad piece. The truth is that piece is rejected, but you have failed to reject because your quality inspections, your detection mechanisms are not good enough. So the bad part got escaped and it went into the consumer. So that's a consumer risk. So let's say the truth is like the part is good, but you have rejected in-house. And this is called producer risk, which means that, you are not able to find out the difference between the good part and bad part, and you have rejected the good part, and the producer is under risk. So this is with few slides because this is a bigger topic. We'll have a lot of examples later. So if alpha and beta risk is clear, the type 1, type 2 error is clear, type super clear SC in the chat box. And thank you for bearing with me because this is one of the intricate subjects in inferential statistics. Okay, if you found this useful, valuable, fantastic, awesome, just put it in the chat box. I need inspiration too. Okay, so if you reject, if the truth is, if the part is good, you should fail to reject. And if the truth is the part is bad, you should reject. Then it is a correct decision. So inferential statistics examples can be n number. I'll quickly share with you a lot of examples. Okay, like suppose the mean mark of 100 students in a particular exam. Okay, particular country is known. Using the sample information, the average marks of students in the country can be approximated using inferential statistics. That's what they also say, no? Okay, your IQ levels, also they have a parameter by which they infer that the country's IQ level is so much, the state IQ level is so much, the college IQ level is so much. All of them are based on inferential statistics. Okay. All right. Even let's say that, there is a coffee shop. Mr. A wants to open a coffee shop in New York. To design the appropriate menu, he conducts a survey of 300 residents, okay, with different tastes and preferences. So the survey includes people across the gender, age groups, and income class. So after using the inferential statistics, the result are 70% of the women like caramel, 50% like cafe mocha, 100% likes American coffee, 25% is coffee latte. So if he infers the data like this, so it's very important for him to conclude that he is confident of including some varieties of coffee in his coffee shop, and also he can also introduce the new flavors and give rich drinking experience to his clients. So these are some uses of inferential statistics. So I've given you this detail of inferential statistics versus descriptive statistics. I'll give you this presentation. I will also give you this recording if you stay till the end of the session. Okay, all these differences are written here. So the 5 steps are: what do you really want to know? Which tool will you have that information? What kind of data tool do you require? How to collect the data? How confident are you of the summaries? Are some of the questions that you need to ask. Now, confidence interval is nothing but, okay, if you say I'm 90% confident, if you repeat this experiment 100 times, on 95%, you'll be correct. That is what is confidence interval means. So you will also find this confidence interval as a part of this statistic. Now, there are a lot of tests that we will be going deeper into: the ANOVA test, the Wilkinson's test, Mann-Whitney's test, Christopher's wallet test, and so on and so forth. This is beyond the scope of today's lecture, okay? And these are some of the deeper tests that we will use for analysis. So are you ready for Q&A? Type ready in the chat box. I'm going to have a simple Q&A. So there are only basically 5 questions here. What is the primary objective of inferential statistics? Is it to summarize the data, to visualize data using charts, or to draw a conclusion about population based on sample, and to collect the raw data? I'm sure all of you will answer this right. Yeah, to draw a conclusion about population based on the sample. Fantastic answer. Okay, question number 2. Which of the following is not a type of sampling method? Not a type of sampling method. Simple random sampling, systematic sampling, cluster sampling, histogram sampling. Which is not a sampling method? Of course, it's a histogram sample, because that is something that we have not discussed about. Fantastic. All right. Third question. Which of the following is not a type of inferential statistical analysis? Regression analysis, hypothesis testing, descriptive statistics, confidence interval. Okay. Descriptive statistics, because we are talking about inferential statistics. In inferential statistics, confidence interval is a very important component. Okay. And we said regression analysis and hypothesis testing is also a part of it. Okay. Last couple of questions. In hypothesis testing, what does a confidence interval represent? The exact value of population parameter, the percentage of data in the sample, a range within which the population parameter is likely to fall, the number of observations in the data set. Okay, I've just articulated just a few minutes back about this confidence interval. Let's say, yeah, C is the right answer, the range in which population. Okay, the last question here is this. Okay, the last question here is for today is this: which of the following is an example of inferential statistics? Calculating the average salary of 100 employees in the company, determining the most common blood type in the hospital, estimating the average salary of employees based on sample, creating a bar chart of the sales data. Which is the following example of inferential statistics? Yes. All right, estimating. All right. If you found today's session interesting, useful, valuable, fantastic, awesome, put it in the chat box.